Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello students, welcome back. Today let us learn something about instructions. Yes, let us spend some time today in learning about instructions, types of instructions, instruction formats and the addressing modes. Okay, so if anybody questions you what is an instruction, if anybody questions you what is an instruction, the answer would be instruction can be a statement or a word given to a machine to perform a particular task, and these instructions should be predefined with respect to the assembly used. For example, if you talk about a high level language, if you talk about C and Java, the instructions you define for C and the instructions you define for Java are the equal. Might be their functionality is same, but the syntax and the structure of the instructions differ, right? So whenever you use an instruction, whenever you write an instruction, that instruction should be well defined in that particular language. Whether it is a high level language or it is a machine level language or an assembly level language, that particular instruction should be predefined in accordance to that language. Is that fine? Yes. Now moving forward, instructions are well-defined things. Now, any instruction you speak in your daily life has only two things, nothing more than that. Has only two things. Those two things will be, we call it as opcode, we call it as operands. The basic structure of any instruction will be opcode and operands. Now, what is opcode? What is operand? Bole to, if I speak about A plus B, so here plus is called as operation being performed, and A and B are the operands. And here plus is a symbol used to perform addition operation. So in assembly language coding we have opcodes that represent this operation. This is the basic instruction format. The basic instruction format is opcode and operand. You also have things like this: opcodes, flag status and the operands. Depending on the processors used, the formats of the instructions keep on changing. So the basic funda and the basic format is opcode operands. Few processors also use this format: opcodes, flags and operands. I repeat, instruction format is processor dependent. Instruction format is processor dependent. Depending on the processor we use, the format of the instruction changes. But by default, any instruction should have these two things for sure: opcode as well as operand. Right? Now, let me stick with these two, opcode and operand. And this is the advanced level format of this thing. Clear? Yes. And I hope now you got an idea about what is operation and what is operands. Clear? Now, How do you classify instructions? If anybody questions you how many types of instructions are there, then again it is processor specific. When I use the word processor specific, I mean it because different processors have got different number of instructions. And on the whole, the functionality of the instructions remain the same, but the syntax has changed, the count of instructions change. So you can classify instructions on two bases. Basics one is you can classify instructions based on functionality. You can classify instructions based on functionality, and you can classify instructions based on operand memory. Based on operand memory usage. So any processor, irrespective of the processor, instructions can be of these two categories, based on functionality and based on operand memory usage. And few people also tell you that you can classify instructions based on addressing modes. Not an issue, we'll speak about what is an addressing mode in the next few minutes, but for the minute, I classify my instructions based on my functionality and based on the operand memory usage. So instruction set. Now let us step forward. Now what do you mean by the instructions classification based on functionality? When you say the word functionality, it is the operation performed on the operands. Now this story of functionality is again classified into few more types. We speak of the following categories. The first category is called as data transfer instructions. Data transfer instructions. And the second one is arithmetic instructions. The third one is logical instructions. Fourth one is branch control instructions. Fifth one is machine control instructions. We speak about the instruction classification based on functionality in these five categories. First one is called as data transfer instructions. Second one is called as arithmetic instructions. Third one is called as logical instructions. Fourth one is called as branch control. Fifth is called as machine control instructions. We have these five categories. Is that fine? Now, what do you mean by the word data transfer instructions? What do you mean by the word data transfer instructions? The very name specifies that these instructions are used to move data from one location to the other location. Isn't it true? These instructions are used to move data from one location to the other location. Now the question is, in which locations is data found? Now data availability data is available in a register data is available in a memory location and data is available directly. Data is available directly. So data can be found in a register, data can be found in a location, data can be found directly. Now when you say the word data transfer, so data is transferred from R to R, R to R, R to M, M to R, R to R, R to R, R to M, M to R, data to R, data is copied directly to R, data is copied directly to M, data is copied directly to M. So data to R, data to M. So these 5 things are considered. You find one more thing missing, right? What is that one more thing missing? So what about M to M? So this M to M is not allowed. M to M is not allowed. In fact, not supported even. So till date, you can move data from R to R, R to M, M to R, data to R, data to M, but M to M transfer is not allowed. To implement M to M, what should I do? So making it more clear, let's make it as from memory location 1, I want to copy it to location 2. I want to copy data found at location 1 and to copy it to data at location number 2. In that aspect, what should I do? In this aspect, to make it happen, first copy the value of M1 to R and then copy the value of R to M2. This is allowed, but directly M1 to M2 is not allowed. Okay, so these are the various types of formats found in data transfer, and depending on the processor you use, the instruction syntaxes changes. For example, if you write MOV, let me explain the story. With respect to 8085 microprocessor, with respect to 8085 microprocessor, I can say R to R as move some A comma B. So B is a register, A is a register, I'm moving the value of B to A, R to R. I can say move M comma A. The value of A is copied to M. And I can say move A comma M. The value of M is copied into A. M is the memory location identified. M is the memory location identified by the register pair HL. So don't worry about that. And the other case, I can say MVI A comma 23H. So this is my data. My data copied into A directly. I can say MVI M comma 23H. MVI A comma 23H, MVI M comma 23H. Different formats are there. Okay, and not only this, you can even directly store, you can load. Okay, so this is the basic aspects of data availability in a processor and the various transfer schemes found R to R, R to M, M to R, data to R, data to M. These are the various things supported by any microprocessor. And keep in mind, S M1 to M2, M to M is not allowed, never. M to M is never allowed. So this is not happening directly. Then what should we do? You need to transfer M1 to R and then R to M2. This is how it happens internally. It should be programmed to happen like this or in this format only. This format is not supported. Is that fine? Yes. Now, shall I remove this? Please copy it down fastly. So if I'm done with this, then so we say in data transfer we do two things only. First thing is we load data into R into M, or we store data. So any operation will be found between these two things only: load, store, and of course we exchange. Yeah. So we have operations with respect to load, operation with respect to store, with respect to exchange, and with respect to move. So four types of things found in data transfer instruction format. Now coming to arithmetic instructions. Now what do you mean by the word arithmetic instructions? As the name says, arithmetic operations are addition, subtractions, multiplication, division, right? Yes or no? So a few processors support only addition, subtraction, incrementation, decrementation. Few support addition, subtraction, incrementation, decrementation, multiplication, division directly. For example, your 8085 microprocessor supports addition, subtraction, increment, decrement. It does not support multiplication and division directly. No way. Then what does it should do? We should perform multiplication as repeated addition and division as repeated subtraction. Whereas in 8086, you have instructions to perform multiplication and divisions directly. Yes. So again, arithmetic instructions are processor specific, where the operations defined can be done directly sometimes, can be done indirectly sometimes. Fine. So what are the operations you perform here? You perform additions, you add, you subtract, you multiply, you divide, you increment, you decrement. We add, we subtract, we multiply, we increment, we divide, we decrement. Fine with that? So these are the various arithmetic instructions found, and the operations are again processor specific. As I gave you the example earlier, multiplication, division are not supported directly by 8085, but those are done directly in 8086. So they are again processor specific. So coming to the story of logical instructions. What are logical instructions? Whenever you need to check multiple conditions and they are connected, if you want to check connected multiple conditions, then we use logical connectives like logical and, logical or, logical not. Clear? So we have operations that can perform, and operation, or operation, not operation, XOR operation. We have and or not XOR, and we also have compare operators. Now let us learn something about compare. Compare, subtract, they go hand in hand with some small differences, with some very small differences. What are those small differences? Now when I ask you a question, 23, I say compare 23 with 18. Even a student of class 1 will tell us that 23 is more than 18. Now the question is how? How is 23 more than 18? If you ask yourself that question, how is 23 more than 18? Then 90% of the students will give you answer that, sir, in number system 23 comes after 18, hence 23 is more than 18. Good, fantastic answer. But how does a machine know that 23 comes after 18, right? Whenever you are talking concepts, talk the concepts with respect to machine. A human knows that 23 comes after 18 or 18 comes before 23, so you compare, get an answer. But coming to a machine, how does a machine understand that 23 is greater than 18? So for that to happen, it does something like this. If you are comparing A with B, it performs A minus B. You get C. So if C is 0, then A is equal to B. And if C is positive, then A is greater than B. And if C is negative, then A is less than B. So this is how it performs comparison. So comparison is also performed by using the concept of subtraction. So what happens is, it performs A minus B, and based on C we jump to conclusions. Now the question is, sir, what is the difference between subtract operation and compare operation? So let me give you a quick difference there. When you say subtract and you say compare, what happens? What happens is, in this case, it performs R1 minus R2, and the result is brought back to R1. So what happens is, any data stored in R1 or the previous data of R1 is removed and the result is kept in R1. So the value of R1 is lost. The initial value of R1 is lost. And in this case, when I say compare R1, R2, it only performs R1 minus R2. And the results are not stored in either R1 or R2, and the results are kept in buffers. As the results are kept in buffers, the value of R1 and R2 are retained. As the values of R1, R2 are retained, we jump to conclusions saying that A is more than B. A is less than B. Is that fine? So the difference is, when you perform a subtraction operation, the initial value of R1 is lost and the initial value is overwritten by the result value of R1. So in this case, R1 value is lost. The result is found in R1. Whereas in compare, the initial value of R1 remains the same and the results are not copied into R1 or R2 but in some other place. So in subtraction operation, the initial value of R1 is lost and in compare the value is not lost. So keep that in your brain. And then we perform AND or not, XOR and compare. Compare is that. And coming to this story called as branching. And what do you mean by the word branching? So branching is a procedure where you move the control according to your convenience. What do you mean by according to my convenience? What do you mean by the word according to my convenience? Now assume that you got I1, you got I2, you got I3, you got I4, you got I5. The sequence is 1, 2, 3, 4, 5, isn't it? So 1, 2, 3, 4, 5. Assume that 1 is finished, 2 is finished, 3 is finished, 4 is finished. Then after 4 you should get 5. After 4 you should come down to 5. But if I want to re-execute my instruction 2 and 3 again, so I write a logic to move my control back to 2 instead of 5. At my instruction 4, the story says 1, 2, 3, 4 and 5. After 4, the control should come down to 5. But I wrote a logic such that my control goes back from 4 to I2. Case 1. And assume that I have a case 2, I1, I2, I3, I4 and I5. I1 is finished. At I2, I wrote a logic to I4 where I am bypassing my I3. Story says 1, 2, 3, 4, 5, but I am saying 1, 2, 4, 5. 3 is gone. It means that depending on the functionality, depending on the requirement, you can move your control from one point to another point. You can move your control from one point to another point according to the requirements. So it is 1, 2, 4 and 5. So this is called as branching. We call it as branching. You are branching your control to the required location. We define a label here. If you can recall your C language, we have go to statements in C language. If you can recall. See, we say go to label. And go to is called as unconditional branching, right? So we have two types of looping statements, unconditional looping and conditional looping. So here branch control is one such category where you can move your control from a particular instruction to the required location irrespective of the sequence. Sequence is not an issue here, you can move. And the instructions we have under branch control instructions are, we speak about jump instructions, we speak about jump, we speak about call, and we speak about return. Jump instructions, call instructions, return instructions. And these are again two types. First one is unconditional. And second one is conditional. First one is unconditional, second one is conditional. Yes. So if it is unconditional jump, then the control moves to the required label without verifying a condition. I mean, it goes normally. There is no specific reason why it is being branched to a label. We call it as unconditional jump, unconditional call, unconditional return. Now, what do you mean by the word call and return? We have learned a concept of subroutines or functions in C language, right? So what is a function in C language? A function in C language is an area where you write a logic in support to the main block. We have a main method, main program, main block, and you write a function called as factorial. And this factorial method is written in support to the main method, isn't it? Yes or no? So we write this function called as factorial in support to the main block. So you need to move your control from main block to factorial method and again come back to main block. So main to fact, fact to main. So similarly in assembly language programming, we have a concept like this is one routine and this is my another routine called as subroutine S1, S2, S3, S4. The sequence is I1, I2, I3, I4, I5, and at I2 I want to go to S1 instead of I3. I repeat my line. At a point called as I2 I want to go to S1 instead of I3. So we have a function call, we invoke a function, right? We speak about calling function and called function. In this case, this routine 1 is calling routine 2. So calling routine, called routine. So I2 is invoking S1 memory, right? So you are branching main method to your sub method or the subroutine. And this happens internally in assembly coding by an instruction called as call. You call this subroutine from the main routine. So call instruction. You observe that again the control is going from I2 to S1, not in a sequence. So this is called as branching. And again back, once the branching part is done, you should again go back, right? You should again go back to I3. Yes or no? So you are going from I2 to S1, S4 to I3. So to go from S4 to I3, we write return statement. So call, return, unconditional call, unconditional jump, unconditional return. 3 categories. And similarly, we have conditional jump, conditional call, conditional return. Now the story is, sir, what do you mean by the word conditional call? What is conditional return and what is conditional jump? In any microprocessor, we have a concept called as flag register. A flag register contains set of flags that tells you the status of the current operation being performed. For example, we have a flag. Basically, a flag is a status bit. Assume that I got a flag called as 0 flag. Okay, 0 flag is set to 1. I mean Z is 1 and Z is 0. Z is 1 when result is 0. Z is 1 when result is 0 and Z is 0 when result is not 0. So I frame a logic: jump if Z is 1, jump if Z is 0, call if Z is 1, call if Z is 0, return if Z is 1, return if Z is 0. So you perform conditional jumps based on your flag bits. One such flag is 0 flag. You also have flags called as, we have a parity flag, we have a carry flag, we have sign flag, we have an overflow flag, we have an interrupt flag, right? We can define n number of flags. So depending on each flag status, I can say jump if carry. What do you mean by jump if carry? So move to a required label if carry flag is set to 1. I say jump if positive. What is if positive? It means that if the most significant bit is 0, if the most significant bit is 0, it is the positive value. So depending on my sign bit status, I make a branch control. I make a branching. So what is parity? Parity indicates number of ones found in the result. If the number of ones are even, I conclude something. If the number of ones are odd, I conclude something. So jump if even parity, jump if odd parity. You can frame things according to the convenience, according to the program logic. So please keep in your brain that we perform conditional branching based on the flag status, based on zero flag, based on parity, based on carry, based on sign, based on overflow, based on interrupt. And I hope you all know the word interrupt. What is interrupt? Interrupt is a signal generated seeking for the processor time. We'll come to it in detail in the later classes, but for now, keep that. Interrupt is a signal generated asking or seeking for the processor time. So that is all about your branch control. So keep in your brain, branching is a procedure of moving your control to the required position, and sequence is not a criteria. You need not go sequential. You can go to the required location. Clear? We use jump, we use call, we use return things. Is that fine? Yeah. Now, coming to machine control instructions. Now, what do you mean by the word machine control instructions? The very name says these are the instructions designed to work with the machine. Like we have instructions called as IO based instructions. If you want to transfer data from the device to an output device, or if you want to get data from a device, external device to a processor, we use machine control instructions. Okay, so IO transfers are basically called as machine control instructions. And if you have instructions which are stack related, instructions, and if you want to speak about an instruction called as no operation, if you want to suspend your processor for small amounts of time where you don't want to make your processor do anything, and if you want to create some delay, we use something called as no operation. You can stop your processor functionality. By using halt instructions. I mean, again, these instructions are again processor specific, right? The functionality remains the same. But when you use an OP in 8085, it has got something else in 8086. I say HLT in 8085. It's something else in 8086 or something else in 286 or 386. But finally, the ultimate functionality remains the same. Any processor you speak about, all those processors work based on these 5 things only: the data transfer part, the arithmetic, the logical, the branch, and the machine control instructions. Fine. So load, store, exchange, move are data transfer. Add, subtract, multiply, divide, increment, decrement are arithmetic. And or not, XOR, compare are logical. Jump, call, return are branch control, and IO, stack, NOP, halt, and few more are machine control things. So this is how we speak about the instruction set based on their functionality. From this concept, few things to be kept in mind. First thing is, there is a difference between compare and subtract. The difference is, in subtract, the initial value of the registers are lost, whereas in compare, the data retains. Second thing, how do you perform branching? Based on conditions, we generate conditions based on the flag values. If flag value is something, we do a condition. If it is something, we have a condition. So please copy it down carefully. Copied that? Fantastic. Good. I hope that you got some idea on different types of instructions based on functionality discussed, right? Now, let us throw some light on the concept of addressing modes. Now, the word addressing indicates referring. Sorry. When I speak of pointers, in the topic of pointers, we have learned that we handle the value of a location by its name and by its address. So when you are using a pointer, you are referring to the address, right? We address that location to get the value. Similarly, the concept of addressing modes, so in the concept of addressing modes, it's all about referring. What do you mean by the word referring? Mode is a method. In English, modes indicates methods. Methods of addressing. Addressing indicates what? Referring or specifying. So addressing mode is all about different methods of specifying data as an operand in an instruction. Let me make it simple, sweet and straight. Addressing modes specify different methods of specifying the data as an operand in an instruction. We have learned that an instruction has two parts, opcodes and operands. Yes. Now we have seen that data can be found, the data availability is in R registers, data availability is in M memory locations, data availability is found directly. So how do you specify your data as an operand? What are the methods available of specifying the data as an operand in an instruction? So those different methods, those different things can be learned in the story called as addressing modes, right? So addressing modes, method of addressing the data as an operand in an instruction. That's it. And addressing modes are of two types. First one is called as non-computable addressing modes. Second one is called as computable addressing modes. Second one is called as computable addressing modes. So we have categories under non-computable addressing modes and we have categories under computable addressing modes. So what are those categories? We'll see in detail in the next session. Okay, that's for now. Thank you.